Welcome to Small Code Learns. In this video, we will see one of the main pillars of OOPs, inheritance in C#. Let's make it super simple and clear. Here's what we're going to cover step by step. 1. What is inheritance? 2. A real-world example to understand it better. 3. And the different types of inheritance with real-world examples. 4. Advantages. 5. Disadvantages. First, we'll see, what is inheritance? The inheritance is one of the main pillars of OOP's concept, along with encapsulation, polymorphism, and abstraction. In simple terms, inheritance means derived class to access the fields and methods of a base class. This helps us avoid duplicate code and organize related classes.
Let me go for real-world example. Let's think of it like this. We have a class called animal. All animals can eat and sleep. Consider animal as the base class with the methods eat and sleep. Now, introduce dog as a derived class that inherits from animal and has its own method, bark. We extend animal by creating the dog class. The dog class wants to use the eat method from the animal class instead of creating a new method. In inheritance, the derived class can access the fields and methods of its base class. In this scenario, the dog class accesses the eat method in the animal class using its own instance, without creating a separate instance of animal. When running this program, the dog instance calls the eat method inherited from animal first, then calls its own bark method. Now you understand what inheritance is.
Types of inheritance in C#. 1. Single inheritance. 2. Multi-level inheritance. 3. Hierarchical inheritance. 4. Hybrid inheritance. 5. Multiple inheritance. Not supported in C#, but we can achieve multiple inheritance via interface. Let we go for each type with real-time examples. First, we will see single inheritance. A class inherits from one base class. Example, dog inherits from animal. We saw this example already. Let's go through it. Next, we will go for multi-level inheritance. A class can inherit from a derived class, creating a chain of inheritance. This means a class gets features from its parent class, and that parent also gets features from its own parent. For example, consider 3 classes: animal, dog, and puppy. And animal is the base class. Dog inherits from animal. Puppy inherits from dog. The animal class has an eat method. The dog class has a bark method, and the puppy class has a weep method. If we want to access the bark method from dog and the eat method from animal and the puppy class, we can create an instance of the puppy class. Using that instance, we can easily access all the methods from each of its base classes. Let's run the program and see the output. From the puppy class instance, we successfully called all the methods from its base classes. Next, we will go for hierarchical inheritance. Multiple classes inherit from the same base class. Example, dog, cat, and bird all inherit from animal. Consider 3 classes: animal, dog, and cat. Animal is the base class. Dog inherits from animal. Cat also inherits from animal. The animal class has an eat method. The dog class has a bark method. The cat class has a meow method. In the main method, we create an instance of the dog class and call eat and bark. We also create an instance of the cat class and call eat and meow. Since both dog and cat inherit from the same animal class, they both have access to the eat method defined in animal. Output. From the dog and cat class instances, we successfully called the method from the base class, animal, as well as their own specific methods, bark and meow. This shows how hierarchical inheritance allows multiple derived classes to share the functionality of one common base class. Next, we will see hybrid inheritance, a combination of 2 or more types of inheritance. Example, a mix of multi-level and multiple inheritance. In this case, it combines single inheritance. Parrot inherits from bird. Multi-level inheritance. Bird inherits from animal, and parrot inherits from bird. Interface inheritance. Bird also implements the iFly interface. So this is a mix of multi-level and interface inheritance, which forms a hybrid. Consider 4 elements: animal, iFly, bird, and parrot. Animal is a base class. iFly is an interface with a fly method. Bird inherits from animal and also implements iFly. Parrot inherits from bird. The animal class has an eat method. The iFly interface defines a fly method. The bird class inherits from animal, implements iFly, and defines the fly method. The parrot class inherits from bird and adds a new method called talk. In the main method, we create an instance of the parrot class. From this instance, we call oEat from animal oFly, from iFly, implemented in bird oTalk, from parrot. Since parrot inherits from bird, which already gets features from both animal and iFly, parrot can access all these methods. Output. From the parrot class instance we successfully called the method from the base class animal, eat, the method from the interface iFly, fly, and its own method, talk. This shows how hybrid inheritance allows a class to combine features from both classes and interfaces, giving it more flexibility and power. Next, we will see multiple inheritance. A class inherits from more than one base class. Note, not directly supported in some languages like C#, but possible via interfaces. What is interface? An interface in C# is fully abstract. It contains only method declarations, no method bodies. The class that implements the interface must define the method behavior. Let we the example. Consider 3 elements: iFly, iSwim, and duck. iFly is an interface with a fly method. iSwim is another interface with a swim method. Duck is a class that implements both iFly and iSwim. The iFly interface declares a fly method. The iSwim interface declares a swim method. The duck class implements both interfaces and defines the behavior of fly and swim methods. So this is a form of multiple interface inheritance, where one class uses multiple interfaces to define different behaviors. In the main method, we create an instance of the duck class. From this instance, we call oFly from the iFly interface, oSwim from the iSwim interface. Since duck implements both interfaces, it must provide the actual method definitions. Output. From the duck class instance, we successfully called the method from the iFly interface, fly, and the method from the iSwim interface, swim. This example shows how multiple interface inheritance allows a class to combine features from more than one interface, letting a single class behave in multiple ways. It is a powerful way to achieve abstraction and flexibility in C#. We saw all the types of inheritance with example. Next, we move to advantages and disadvantages of interfaces. Advantages of inheritance, with simple explanations. 1. You can reuse code from the base class. Means instead of writing the same code again, child classes use the methods and properties from the base class. 2. Child classes can change or add behavior. It means child classes can have their own methods or change how base class methods work. 3. It helps organize code better. It means grouping similar things together makes the program easier to understand. 4. You can add new features by making new classes. It means you can create new child classes that have extra abilities without changing the old code. 5. Fixing bugs in the base class helps all child classes. It means when you fix a problem in the base class, all the classes that use it automatically get the fix.
Disadvantages of inheritance, with simple explanations. 1. Changes in the base class may break child classes. If you change something in the base class, it might cause errors in the child classes that depend on it. 2. The base class is tightly connected to child classes. Child classes rely heavily on the base class, so they are linked closely. 3. Big inheritance chains can be confusing. If many classes inherit from each other, it can be hard to keep track of what each class does. 4. Inheritance is not always the best choice. Sometimes using other ways like composition, using objects inside objects, is better. 5. Using inheritance too much can make code complex. Overusing inheritance can make the program hard to understand and maintain.